Yeah, good evening, sir. Myself, Shashidhar Reddy Malagireti. Yeah, my registration is 19DC1646, and this is my digital assignment to video. So here, my topic is DSA digital signature algorithm. So here we'll see what is a digital signature and what is electronic signature. What are the differences between electronic and digital signatures? How it is a digital signature? How it works? And how hard it uses? How hard it to use? Is a di- is a digital signature legally enforceable or not? We'll see in this session. I mean, in this assignment. So here, generally, we'll see what is a digital signature. Digital signature is a type of electronic signature that encrypts documents with the digital codes that are particularly difficult to duplicate. A digital signature takes the concepts of traditional paper being signed and turns into an electronic fingerprint. The fingerprint is known as a coded message. Fingerprint is known as a coded message. Is unique to both the document and the signer binds them together. So it is used to evaluate the authenticity and integrity of the message software or digital document. It generally used to validate the authenticity or authority of the message or software or digital document. Digital signatures cryptographically bind an electronic identity to a document, like a signature to a document. The signature cannot be copied from one document to another document. See here, the original text is being signed by using the private key of a person. Is a signed text. It can be verified by using a public key, but the original text cannot be changed here itself. Only the owner can change the original text, then it has to be signed again with this with the private key. Then the signed text it can be verified using the public key. Digital signature technique is based on a public key cryptography with a difference. Public key cryptography, a pair of keys you are used. One is a public key and one is a private key. These are used for the encryption, decryption. These are used for the encryption and the decryption of the messages. However, in a case of digital signature, message is encrypted with the private key and decrypted with the public key. One only a specific person with a correspond. I mean, only a person who has a private key can encrypt the message, or in those words, they can sign the message. However, the party who has a signature public key can decrypt the message. In other words, he can verify it's in the message, the original message is there, or it changed or not. It will be you verified by using the public key. So here, let's see how it works simply. Alias has a clear text here itself. It is signing by using the private key of alias, and we get the at the end we get the signed message. And the signed message uh, signed message cipher text. Simply it's a cipher text. Bob takes the cipher text and the public key of alias. He verifies and he decrypts the cipher text into the clear text. He gets a original message what the alias has sent to the Bob. The confidentiality issues in DSA digital signature algorithm is it should be possible for receiver. It should be possible for the receiver of a message to ascend its origin. Intruder should not be able to change masquerade as someone else. It should be possible for the receiver of a message to verify that it has been modified in transit or not. Intruder should not be able to substitute a false message for a it simply tells that receiver should be able to verify the original message. I mean, message that received from the sender, it's a original message or not, and also it should defend the intruders to change the original message and keep the false message in place of that. It is one of the confidential confidentiality issue in this thing, and the sender should not be able to falsely deny later that he has sent a message. Now we'll discuss about the attributes of digital signature. Your digital signature ensures the confidentiality via the following three attributes. The attributes are authenticity, integrity, and non-repudiation. Let's see what is meant by authenticity. Authenticity is the authenticity of digital signature. Authenticity means the act of proving who you are. Who you are. Authenticity means that you know who created and sent the message. Digital signature is used to authenticate the source of message. It ensures the user of the sender. Simply, authenticity helps to find the message, who sent the message and who created the message. By using authenticity, you can say that he created the message and he sent the message to someone else. What is meant by integrity? Integrity ensures that when a message is sent over a network, the data that arrives is the same as the data that was originally sent. Integrity is the assurance that the information is trustworthy and accurate. Digital signature ensures the integrity. Here, simply, another word, integrity means simply verifying the message that has been sent by the sender to the receiver. Simply as I send message to the Bob. Here, the Bob has a integrity analyzed. So, integrity means simply just verifying the message that sent from the sender is the same as the message that's received by the Bob. Is the same or not? Just it's verifying the same data came to the receiver or not. Non-repudiation. Repudiation. This is the important criteria of this is the important criteria of the digital signature. Digital signature ensures the authentication of the message, so sender cannot repeat it later. At the same time, it also ensures the identity of the receiver, so the receiver cannot change the message what the sender sent it later. What is electronic signature? Electronic electronic signature is a type of name or a scanned image of handwritten signature, and as a result, e-signature is very problematic when it comes to maintaining integrity and security, as nothing prevents from one individual from typing another individual's name. So, due to reality and electronic signature does not actually incorporate additional measures of security. So, it does not have that much security. So, simply anyone can, from any individual from one of my friend or anyone can write his name in place of mine. So, that's the problem here in the electronic signature. Difference between digital and electronic signature. The digital signature often referred to advanced or secured version of the electronic signature. Simply refers to the advanced or secured version of the electronic signature that provides high levels of security or universal acceptance. A digital signature normally based on public key infrastructure (PKI) technology, grant a signature identity, intent, and data integrity, non-reputation signed of documents. The digital signature cannot be copied, tampered with, or altered because every individual has an individual digital signature. It normally can't. It's not easy to get a digital. I mean, it's not easy to get your own digital signature that much. There is some procedures to get your own digital signature. Is digital signature legally enforceable? Yes, in 2006, the Parliament of Bangladesh enacted ICT Act 2006, which made a signature signed electronic documents as legally binding as a paper basis. What is the standard? The three algorithms that are suitable for a digital signature generation under DA-2 standard. They are digital signature algorithm, and RSA, and elliptic curve digital signature algorithm. Now we'll discuss about the digital signature algorithm. Here, digital signature algorithm. So now we'll discuss about the algorithm using digital signature algorithm. Now we'll take the sender's place. I mean sender's part. Firstly, senders takes an input message, as you see here. Now senders takes an input message, and there is the input message into the algorithm using there is the input message using message digest algorithm. Then we have to apply the DSA. We have to apply the DSA using the private key to encrypt the digested message. The digital signature is padded into the digested message. Here, the digital signature is padded into digested message, the third part. Now we have to create a data pack using the original message plus encrypted message. So now to send the pack to to the intended receiver. So this is the data packet, encrypted message plus. Now we have to send the packet to the receiver who wants, to the receiver. Now receiver receives the data packet. So as we see here, and separate the original message plus encrypted message. So now apply DSA using public key on the encrypted message. So to decrypt this stage, the digital signature is removed from the message. So the place what we say, the message by using the public key, we can from the encrypted message, we can separate the signed part, like signed message. We can separate, then we'll get the original message. What we get the digestion message, then we compare them. Message not tampered and message tampered. DSA parameters. What these are the parameters for the digital signature algorithm. DSA completely. DSA digital signature is computed using a set of parameters. For this for computation, we need some parameters for encryption decryption using DSA. The parameters are private key X, pair message or data secret number K, random data secret number K, data to be signed, and have hash function. These four need to be there to encrypt the algorithm. For the signature verification, we need to have the public key of the user, sender, and the data to be verified, like and the hash function, like the data packet, which is signed by the private key of the sender plus message, need to be there for the signature verification. And not only that, but the parameters are defined as follows. There's some limits. Okay, I'll explain now. See, P is a prime modulus where P should be in the range of 2 power L minus 1 to 2 power L. L is a bit of length of the P. Values of L are provided in the section 4.2. We'll see later. Prime to measure P minus 1, where 2 power N minus 1 Q 2 power N. So these are some G is a generator of subgroup or of mod P. So G should be the range of 1 to P. The X is the private key, Y is the public key. X is a secret number that is used for each random number. The PQG are the public, and X is the private, Y is the public key. And some other parameters we're going to discuss right now. Yeah, selection of parameter sizes. Selection of parameter sizes and hash function for DSA. The standard, there are some standard specific sizes. There are some standard specific sizes of for the following choices for the pair of L and M for the bit length of P and Q respectively. So L is equal to 1024 bits, then it should be not more than 160 bits. Like 2048, 224, 2048, 256, 256. These are the standard bits. So now we'll see how signature is generated by the sender. So here let n be the here let n be the length, bit length of Q. Simply the signature M consists of pair of numbers R and S that is computed according to following equations, where R equals to G power K mod P mod Q, Z is H of M, so S equals to K minus 1 H of M plus X mod N. While when computing is the string Z obtained from the hash is converted to an integer, so RS is considered the signature of the sender. RS is considered to be signature of the sender, like a private. So generally, R value can't be 0 if signatures are properly generated. It's very extremely rare that R equals to 0 is equals to 0. If either R equals to 0 is equals to 0, A new value of k will be generated, and the signature shall be, I mean, signature should be recalculated. So the signature RS is transmitted along the message to the verifier. Here, how signature is verified by the receiver. Signature verification may be performed by any party, the signature like sender or intended receiver or any other party user by using simply if you have the public key of the sender, you can verify it yourself. There is no specific person to verify. No one, anyone public key can verify that thing. The signatory may wish to verify the computed signature is correct or not. Before sending the signed message to the intended user, the intended user verify the signature to determine the authenticity upon receiving the message. Let MRS is the received versions of MRS. If everything goes right, then M dash equals to M, R dash equals to R dash equals to M. Then let Y be the public key of the claimed signatory, and let N be the bit length of Q. So the signature verification process are followed. The verifier will check if R dash is lies between 0 to Q. If either condition is valid, the signature shall be rejected as invalid. Yeah, the two conditions in step 1 are satisfied. The verifier computes the following. If first we have to calculate the value of W, then Z, U1, UV, then V. If V equals to R dash, then the signature contribute to be verified. If we M equals to M dash, R dash equals to R, S dash equals to S, V equals to R dash, then signature is verified. If V equals to V not equals to R dash, then the message or signature may have been modified. The signature is considered invalid. LS wants to send message to now let me explain. Let me explain you the thing. This thing with an example. Like if LS wants to send message into the bomb, those now we'll discuss about this. Discuss the sender side. So here, LS generates a random number k less than k. LS generates R. We have these equations. Will value R and S. Then the parameters R and S are his signature. She sends these to Bob along the sign message. Then the receiver side, we're going to calculate the WZ, U1, U2, V as we discussed in the algorithm. So after calculating, if the V equals to R dash, then the signature message can consider to be authenticated. If V not equals to R dash, signature message is considered invalid and message something change is done, someone tampered the message. It's considered like that, and a message will be invalid and signature also will be invalid. This is the reference where taken. Thank you, sir. Myself, Shishi. Once again, myself, Shishi. Ready, Mali ready, 19DC 1646. This is my DA-2.